Hello and welcome, I'm your Code Monkey. In this lecture we're going to add the ability for the player to be carrying a plate and pick up objects onto that plate. Okay, so here we already have the plate counter working. It has some basic logic. After a bunch of time it spawns a plate, it spawns up to a certain maximum, and I can pick up a plate, and yep, the player is carrying a plate, so I can put it anywhere. Then I can, for example, pick up some tomatoes, slice them, and pick them up. However, now I am not able to place the tomatoes on the plate. So let's add that logic. Let's begin over here on the clear counter script. First, we're testing if there's no kitchen object here, and the player is carrying something, that the player drops something in there. But then we're testing if there is a kitchen object here, and if the player is carrying something. So it's over here that we want to check if the something that the player is carrying, if it is a plate. Now our plate is also going to have a bit of custom logic. So to help both identify and hold that custom logic, let's make a proper script to handle it. So back in Unity, let's create a brand new script. Call it the plate kitchen object. And let's open this. Now over here on this one, instead of extending mono behavior, we're going to extend kitchen object. So the plate is really just a more specific type of a kitchen object. Again, like I mentioned quite a while ago, you want to be very careful with inheritance. You need to have a very good reason to do it. Here we want the plate to behave exactly like a kitchen object, just with a tiny bit of extra logic, so in this case it makes perfect sense. Let's just go ahead and save this, and wait for Unity to compile. And over here let's find our kitchen object with the plate, so here it is, the prefab. As you can see, we have a kitchen object. Now instead of having that one, let's replace that with the plate kitchen object. And since we are extending kitchen object, we have the same fields, so let's make sure to add the kitchen object as so, and get rid of the other one. Okay, great. So now back here on the clear counter, when there's a kitchen object here and the player is carrying something, we can check if the player is holding a plate, and for that we can check the type. So if, let's go into the player, and let's get the kitchen object the player is holding, and we test if this object is of type plate kitchen object. If so, then that means player is holding a plate. And if that is the case, then we basically want to give the player whatever object is over here, we want to add it to the plate. So let's go into the plate script to add that function. So over here, let's make a public void. Let's call it add ingredient. As a parameter, we're going to receive a kitchen object as so. We really only care about the type. We're going to destroy the actual kitchen object like we've been doing when creating different types. So the plate is really just going to store a list of types. So up here, let's store a list of kitchen object as so for the kitchen object as so list. Then when we add the ingredient, let's just add it to the list. So this kitchen object is so. Let's also make sure to initialize the list. So let's do it on awake. Let's initialize our list. And now from the other side, we just need to call this. So over here on the clear counter, if the player is holding a plate, let's first get the type of plate. So plate kitchen object, or the plate kitchen object. We go into the player to get the kitchen object, and we cast this as a plate kitchen object. Okay, so we have this, and then over here, let's call add ingredient. And let's add whatever is currently on this counter. So let's get the kitchen object and get the kitchen object as so. Okay, so we're adding it to the plate. And then let's destroy what is here. So get kitchen object and destroy itself. Okay, so that's it. So if there is something here, and if the player is holding something, and that something the player is holding is a plate, if so, we're going to add that ingredient to the plate and then destroy the object in here. So let's test. Okay, so here let's pick up a tomato, let's slice it, let's put it on a clear kitchen counter because that's the only one where we added the logic. So on this one, let's pick up a plate, and now whilst I'm carrying the plate, and if I approach and I interact with it, and yep, there you go, it does work. The object vanished from the counter and supposedly was added to the plate. Again, we can use a really nice debug inspector to see it. So let's pause the game, let's select the plate, let's see the plate kitchen object, so here it is, this one, and let's change the inspector into debug mode, and down here, yep, we do see the kitchen object as a list, and it does have some tomato slices. Okay, awesome. So with this here, we have our basics. We can have some ingredient and we can basically pick it up from a plate. Now, one thing about our plate, this is where we're basically going to carry the final recipe that we're going to deliver to the customers. And based on the design that I defined, I want something pretty simple. Meaning for the design that I'm going for, there won't be any kind of double burgers or double cheese. So each final recipe will only have at most one of each ingredient. So let's add some basic logic just to prevent adding duplicates. Over here on the plate kitchen object, when we add an ingredient, since the function will now not necessarily succeed every time, let's actually rename this. And again, use the very useful Visual Studio shortcut. So you can press Ctrl RR or right click and let's rename. Since this function will no longer succeed, we're just going to try to add an ingredient, so try add ingredient, and then let's also make it return a boolean. Basically, for any function where you're not sure if it will succeed, I like to add try and make it return bool. So this way it works pretty much exactly like the try again component that we've already seen so many times. So it tries to do something and returns whether it succeeds or not. So over here, instead of always adding the ingredient, let's see if this one is a duplicate. So let's do an if, and let's go into the list and check if the contains. And if the list already contains this kitchen object SO, if though, then already has this type, so let's return false. And if not, then that means this is a brand new ingredient. So let's add it and return true. Okay, so that's it. Now let's go over here onto the clear counter. So we try to add the ingredient, but then we only want to destroy if this one succeeds. So let's put this one inside an if. So if we do manage to add the ingredient, then yes, let's destroy itself. If not, then we don't destroy anything. Okay, so let's test. So let's go ahead and slice 2 tomatoes. So one, slice it, put it here. Then another one, slice it and put it here. Now let's pick up a plate. Go up here, try to pick up this one, and yep, it does work. Now for this one, and nope, it doesn't work. Okay, great. Now one more thing in our logic. We only want to pick up certain things. Like I said, only things that won't be used in the final recipe. For example, no customer is ever going to request a full entire tomato. The recipes only have sliced tomatoes, so we should not be able to drop a full tomato directly on top of a plate. So let's change that. So over here on the plate script, let's basically just create a list of our valid ingredients. So let's make a serialized field, private, make it a list of kitchen object SO, and call it the valid kitchen object SO list. Okay, so we have this list. And over here in the editor, let's just drag the ones that we want. So let's first of all select the plate object. Okay, here is the plate prefab. And over here we've got all of our kitchen objects. So let's just drag the ones that we want to add to the plate. So the final recipes will have some bread, yep, but they will not have entire cabbages. They will only have cabbage slices. Same thing, no cheese, only slices. For the meat, we're only going to be able to add meat cooked, but also meat burned. Then we're not going to be able to add a plate onto a plate, of course not. And finally, instead of a tomato, just tomato slices. Okay, that's our valid list. And over here, again, it's very simple. So we can just go, if the valid kitchen object is a list, if this one contains the one that we want to add, then we can add it, but if not, then let's return false, not a valid ingredient. Okay, so let's test. All right, so let's pick up a tomato and also some tomato slices. And now if I pick up a plate and I go into the tomato, nope, doesn't work, but the slices, yep, it does work. Okay, great. So here we have all of our basic plate rules. Everything is working perfectly, but it's only working over here with the clear counter. So let's do a little bit of code cleanup, and then let's add this logic to all the other counters. So first, to clean up this code, over here we are testing if this is a plate kitchen object. Then we cast to an object, and then we call the function. So let's simplify all of this. And let's do it just like Unity does with their try_get_component function. So let's make a custom function that takes an output parameter. The best place to put it is on the kitchen object. So here we've got the kitchen object script. Okay, great. Let's scroll down and make a nice function here. So let's make a public. We're going to return boolean in case this succeeds or not. Let's call it try_get_plate. And over here, let's make an out parameter. So don't forget the out keyword. Let's return of type plate kitchen object for the plate kitchen object. And over here, we do exactly what we did. So we test if this object is a plate kitchen object. If so, then let's set the plate kitchen object equals this as a plate kitchen object, and we return true. But if not, then this is not a plate, so let's return false. And one thing when working with output parameters, you always need to make sure to set the output before you exit the function. So over here, that's the error that it's telling us. We must assign it to something when we return. So over here, we don't have a plate kitchen object. So to solve this, we just set this to null. Okay, great. Now over here on the clear counter, instead of doing all of this, basically let's ask the player if this is a kitchen object. So let's try to get the plate. Out plate kitchen object for the plate kitchen object. So you try to get it, then we try to add the ingredient, and so on. Now obviously we could further simplify things by making a function that would try to get the plate and try to add the ingredient. That could work, but since some counters are going to have a bit more custom logic, I think keeping them separate like this makes more sense. So first we try to get the plate, then we try to add the ingredients. So let's apply the same logic to the cutting counter. So over here on the cutting counter, let's scroll down to where there is a kitchen object here and the plate is carrying something. So on the clear counter, we just want to copy all of this. So let's go over here and we do the exact same thing. Okay, that's it. And the other counter from where we can pick up things is from the stove counter. So here we are on the stove. Let's scroll down until we find the interaction. Okay, there's something here. The player's carrying something. So it's over here. Let's do that and do the exact same thing. Except on the stove, again, let's remember that this is using a state machine. So when we pick up something, let's do pretty much the same thing that we did here. So let's make sure to reset the state, fire the events, and so on. Okay, so those are the only counters that we need to implement. We cannot drop things on top of a container. We cannot drop things on top of the plate counter or the trash. So these are the only 3 types that we need to implement. So with this, let's test. Okay, so let's begin with some meat. So let's pick up some meat, put it on the stove. Let's pick up a plate, wait for it to cook, pick it up, and yep, there you go, it does work. Now let's test the cutting counter. So let's pick up some cheese, let's slice it, pick up some plate, and go, and yep, there you go, it does work. And again, if we inspect, we can make sure that it is indeed working. So let's go into the plate, and let's put this on debug inspector, and yep, there we do see this one has a meat patty cooked and some cheese slices. Okay, great. Now the last piece of logic that we need is pretty much the opposite. So right now it works if there's a sliced object on the plate and the player is holding a plate object. But now we want the opposite. So let's say there's a plate in here and we slice some cheese, and now I want to drop the cheese on the plate. So let's do that. And basically for this one is only going to happen on the clear counter. That's the only counter type that can have a plate on top of it. So over here on the clear counter, then we check if there's no object there, but that's not what we want. We want if there's a plate on the counter. So if there is an object there, and if the player is carrying something, then we check if the player is holding a plate. But if not, so if the player is not holding a plate, so player is not carrying plate, but something else. Over here, we need pretty much the exact same logic, except just testing for the object on this counter. So let's do if, let's get the kitchen object on this counter. This one, try to get the plate. So out plate kitchen object for the plate kitchen object. So if so, there's a plate over here. That means the counter is holding a plate. So then let's go into this plate kitchen object. Let's add the ingredient. And we're going to try to add whatever the player is currently carrying. So the player dot get kitchen object and get the kitchen object as so. So we're going to try to add this. And if we can't add, then we're just going to destroy whatever is on the player. Okay, that's it. And over here, we've got a nice error just because we defined it with the same name up here. So up here, we're already defining the variable, and over here, we're defining the same variable with the same name. So we can either give this a different name or just not define a brand new variable here. So just it's defined up here and we're using it here. Okay, so all logic is working. Now here, make very sure that you're not mixing references. Keep in mind when you're referencing the kitchen object on this counter and the one on the player. Those are 2 different things. So over here, if the player is not carrying a plate but something else, then you check the kitchen counter. So over here, you're not checking the player but checking the counter. Then you go into that plate and you try to add the ingredient and you try to add the one that the player is carrying, and then you destroy the one the player is carrying. So again, be very careful here. Make sure you don't mix references. So with this, it should work. So let's make sure to save our script and let's test. Okay, so here we are. Let's first pick up a nice plate. Let's drop the plate in there, pick up some bread, drop the bread, and yep, there you go, it does work. All right, so now we can do a bit more natural interactions. So for example, let's pick up some meat and put it on cooking. And there you go, the meat is fried. So now I'm currently carrying just some meat. So I place it there, then I pick up some bread and put some bread on top of the meat. And yep, everything does work flawlessly. Okay, so here we created a plate and we created some custom logic to define what the plate can and cannot pick up. Now all that's left is actually being able to see what is on the plate, so let's do that in the next lecture.